Hello and welcome. So today we are jumping right into the absolute heart of Python, its data types. Now, I want you to think of these as the digital Lego bricks you're going to use to build literally any program you can imagine.
So, have you ever wondered, how does a computer know that apple, the word, is totally different from 100, a number you can do math with? Well, the secret sauce is data types. Python uses these categories to figure out exactly what kind of information it's dealing with.
All right, here's our game plan. We'll start with text and logic, then jump into how Python handles numbers. After that, we'll look at how to group data together, touch on a couple of special cases, and finally, we'll arm you with the tools to manage everything. Let's get started.
First up, let's talk about text and logic. We're going to look at how Python understands language using something called strings and how it makes decisions with Booleans. Honestly, these are two of the most basic things you'll use in every single program you write.
Okay, so what's a string? Well, its official name is str, and it's basically just how Python sees text. Anything you put inside single or double quotes, a name, a sentence, whatever, Python calls it a string. It's our #1 tool for working with text. But here's the cool part. Strings aren't just stuck the way they are. We can chop them up. This is called slicing. Think of it like slicing a piece of cake. If you look at the code on the left, name 0 to 4 grabs the characters from the very beginning, index 0, all the way up to, but not including, index 4. That's why the output is Pyth. Then, name 2 starts at the third character and just goes all the way to the end, giving us thon. And here's a neat little trick. Name -1 always gets you the very last character. Super handy.
Strings also come with these awesome built-in tools called methods. They're like little power-ups that do common jobs for you in an instant. For example, .upper just shouts the whole string in uppercase. You can see the output right there. .title gives you that nice, clean capitalization on each word. And .replace is a game changer. It lets you find some text and swap it with something else, just like we did, turning world into Python.
So showing plain text is fine, but where things get really powerful is when you start mixing that text with your variables. This is how you create dynamic messages, stuff that changes. It's an absolutely essential skill. And this right here is the absolute best way to do it in modern Python. They're called f-strings. Just look at how clean that code is. You just pop an f right before the quote, and then you can stick your variables directly into the string inside these curly braces. Python just handles the rest, and boom, you get a perfectly formatted sentence in the output. Okay, let's switch gears to our other fundamental Lego brick, the Boolean. It sounds fancy, but it's incredibly simple. A Boolean can only ever be one of two things, true or false. That's it. It's the simple yes or no that guides all the decision-making in your code. And most of the time, you get a Boolean from making a comparison. When you ask Python a question like, hey, is 10 greater than 5? It doesn't just say, yep, it gives you back the Boolean value true. And is 10 less than 5? Of course not, so that's false. These true/false answers are the absolute foundation of how your program makes choices. All right, we've got text and logic down. Now let's talk about numbers. Python actually has a few different ways to think about numbers, and which one you use really just depends on what you're trying to do. The three big ones you'll see are integers, floats, and complex numbers. An int is just a whole number, like 10 or -404. A float is any number with a decimal point, and then there's complex numbers. You'll see those in some pretty specific math and science stuff. For most of what you'll be doing, you're going to live in the world of ints and floats. And of course, you can do all the normal math, right? Addition, subtraction, no problem. But let's check out those last two lines of code. When you use a single slash for division, you always get a float back, a really precise answer. Now that %sign, percent, that's called the modulus. It's a little different. It doesn't give you the result of the division, it gives you the remainder. So 10 divided by 3 goes in 3 times with a remainder of 1. That's why the output is 1.
So we've got our individual Lego bricks, our strings, our numbers, our Booleans. But what if we need like a box to hold a bunch of them together in a specific order? Well, that's exactly what sequence types are for. The most popular container by far is the list. A list is great because it's changeable. The technical term is mutable. So as you can see in the code, we can just reach in and change the first item to orange. No problem. We can also tack new items onto the end using the .append method. Lists are your super flexible go-to container.
And now, let's meet the list's close cousin, the tuple. You'll notice it uses parentheses instead of square brackets. The key thing about a tuple is that it's not changeable. It's immutable. Once you make it, it's set in stone. If you try to change an item, like we're trying to do in that commented out line, Python just won't let you. It throws a type error. Think of it like a container that's been glued shut for safety.
So let's put it side by side. This is the big takeaway right here. Lists are mutable, they can be changed. Tuples are immutable, they are fixed. So when do you use which? Well, you use a list when you know you're going to need to add, remove, or change things. You use a tuple for data that you want to protect, stuff that should never change. And because they're fixed, Python can make them a little bit faster too. Okay, let's quickly touch on a couple of more specialized data types. You won't use them every single day, maybe, but they handle really important ideas like what it means for something to be empty.
And the first one is none. Now be careful. None does not mean zero. It doesn't mean an empty string, and it's not the same as false. It literally means the absence of a value. The best way to think about it is an empty box. You've set aside a place for something, but there's just nothing in it yet.
You've made it. You now know all the core building blocks. So for this last part, let's give you the tools you're going to need to work with them, to figure out what they are, and even change them from one type to another.
First tool in your kit, the type function. It's like a little detective. You can give it any variable, and it will tell you exactly what data type it is. So you can see here, we give it X, and it tells us, yep, that's an ink. We give it Y, and it says that's a string. It's perfect for when you're not quite sure what you're working with. The second amazing tool is typecasting. This is basically your power to change a Lego brick from one shape to another. In the code, we're taking the text 10 and using int to turn it into the actual number 10. We can do the same with float for decimals. And we can go the other way too, taking the number 100 and turning it into the string 100 with str. This is something you'll do all the time. And that brings us to the final blueprint. This is a great little cheat sheet of everything we've talked about. You've got your strings for text, Booleans for logic, ints and floats for numbers, and your lists and tuples for holding collections of things. These right here are the core building blocks you will use every single day. So we've looked at all the essential Lego bricks in the Python language. They might seem simple by themselves, but when you put them together, you can build literally anything you can dream up. So the only real question left is, what are you going to build first? Thanks for watching.